Hello, everybody. So we are finishing the second half of section 3.5, and we had to graph rational functions. Also, we're going to talk about asymptotes that are not vertical nor horizontal. They are, well, they would have to be slanted if they're going to be a line, or you could have asymptotes that are look like parabolas, etc. But remember, with these the vertical asymptotes are always x values that would result in division by zero. That's an easy one. So no rational function on planet Earth will ever cross over a vertical asymptote. Because think about what the vertical asymptote means. It is an x value that would make you divide by zero. So for instance, number 43 right here, negative 5/3 is a vertical asymptote because when x equals negative 5/3, you're dividing by zero. So this function is absolutely undefined. There is no y value attached to x equals negative 5/3. So you would just have a vertical asymptote, and the graph would be bending towards that vertical asymptote on both the left and the right. Horizontal asymptotes only occur when the degree of the top and bottom are the same. Then it's the ratio of the leading coefficients. Like, for instance, this case, it's y equals negative 2/3. Or if the degree in the denominator is greater than the degree of the numerator, like in number 37, then you have just y equals 0. For all other cases, the degree of the numerator is greater than the degree of the denominator, and you don't have a horizontal asymptote. You have and you may have an asymptote, but it's just not a horizontal line. It could be a slanted line. In fact, the difference between the degrees, like this is a third degree versus a second degree, that's only a 1 degree difference. So that tells me that the asymptote is a first degree polynomial. So in other words, it's a line. But if this were 12x to the fourth divided by 3x to the second plus 1, that's a 2 degree difference. So there would be a asymptote that would look like a degree 2. So in other words, it would look like a parabola. But I think all the asymptotes in this unit have, if they're not horizontal, then they would be slanted. They would be a linear with a slope and a y-intercept and everything. So we're going to graph these without technology, and the book has this 7-step process, which is a great exercise. And it incorporates a lot of stuff that we've learned the last few weeks into one problem. First of all, remember a rational function, the ones we are studying, is a polynomial divided by a polynomial. And we're going to first discover if there's any symmetry. So if it's even, it's symmetrical about the y-axis, and that would help us graph it. And if it's odd, it's symmetrical through the origin, and that would also help us graph it. So the first thing we're going to do is plug in the opposite of x and see what we get. Well, for our example right here, x minus 4 over x squared minus x minus 6, when you type in the opposite of x, you get this, which is not exactly f of x, nor is it the opposite. So unfortunately, we have no symmetry. It's not symmetrical on the y-axis. It's not symmetrical about the origin. Step 2 was find the y-intercept. I mean, we should always be finding the y-intercept. It's so easy. Just plug in 0 for x. If I plug in 0 for x, I get negative 4 over negative 6, which is positive 2/3. And that's an ordered pair that I can actually graph. I could start to graph now. 0, comma, 2/3, right about there. So my function is going to be going through this ordered pair. Step 3 would be find the x-intercepts, if there are any, by solving for p of x equals 0. Well, remember, the polynomial divided by polynomial, any number that makes the top 0 would be a x-intercept. So the top is just x minus 4, and there's only one number in the whole world that makes x minus 4 0. That is the number 4. So there is a x-intercept at 4, comma 0. So again, I've got two ordered pairs that I'm going through. Step 4 is find any vertical asymptotes. Well, those are the x values that would make you divide by 0, but they also don't cancel out. So you would have to factor the denominator. This factors into x minus 3 times x plus 2. So there are two vertical asymptotes. Positive 3, x equals 3, and x equals negative 2. And they're graphed right here for us. Step 5, find any horizontal asymptotes. Well, the degree in the bottom is bigger than the degree in the top. So that means y equals 0 is a horizontal asymptote. And then finally, find some ordered pairs, but not just any old ordered pairs. You want to find ordered pairs. Well, you see how it divides the coordinate plane into sectors. We want to find an ordered pair on one side of this asymptote and in between these two asymptotes on the one side of this zero. So in between the asymptote and the zero, and then past that zero. So we've got 4 intervals that we kind of want to find ordered pairs for. And these are just random. So anything you want to pick. You basically want to understand like what's happening to the left of x equals -2. Because if it's a positive number, then you've got, your graph is approaching this vertical asymptote and the horizontal asymptote. If it's positive, it's going to be up here, looking like a curve like this. If it's negative, it's going to be down here. And you only have to test one number because we know if it crossed over the x-axis, it would have had another 0, but it only has 1 0, and it's over here. So we're going to find one number to the left of -3. I'm sorry, of -2, and I just chose -3. You plug in -3, and you get -7/6. So -3, comma, -7/6 is an ordered pair. And so here's -3. -7/6 is -1 and a sixth, so about right there. So you can kind of imagine my function is approaching this vertical asymptote and also approaching this one. So it's going to be looking like a curve like this. Then I need an ordered pair between these two asymptotes. And whenever you have the chance to pick 0, you should, but we already did find that. We plugged in 0 for x, we got 2/3 for y. So that one's already done. Then pick a number between 3 and 4. And I just chose 3.5 and put it into my calculator, and I got -0.18 repeating. So when x is 3.5, the y value is -0.18 repeating. So that's another ordered pair. Here's 3.5 and -0.18. So estimate. And then finally, an x value past that 0, so bigger than 4, and anything you want to pick. And I chose 5. F of 5 is 1/14. So when x is 5, your value is 1/14. So let's analyze what's going on here. Look at it as 3 sectors: the sector on the left, the middle, and the right, because nothing is going to touch these vertical asymptotes. The one on the right, I start on the bottom because remember this ordered pair is 3.5 -0.18, and then I'm hitting 0 at 4, and then at 5 I'm at 1/14. But I have to, it's not going to be skyrocketing up here. I know that as x gets bigger, it's going to be approaching this line right here, y equals 0. So it's now over here, close to the vertical asymptote, it's going to be close to the vertical asymptote, hit through these 3 ordered pairs, and then continue along this horizontal asymptote. And it's going to be really difficult for me to draw that out. Something like that. It's, the way it's drawn is not a function. It's failing the vertical line test right here, but you get the idea, I hope. Now, this middle section, all of the values in this middle section are positive, guaranteed, because it's continuous between -2 and +3, because it's only discontinuous at those 2 points. So it must be continuous on all other points between them. And I know it's because of that, they must all be positive. I know I've got a positive y-intercept right here. I can't suddenly jump down to the negative, because to get down to the negatives, I must have at one point crossed over the x-axis. That means I would have another 0, another x-intercept. And I only have one x-intercept, 4, 0. So because of those two ideas, I know that all the values in this middle section are above x equals 0. So I just draw, I draw something that, making sure it's going through this ordered pair right here. And then finally, my third section over here, knowing that it's going to approach this horizontal asymptote, it's going to approach this vertical asymptote, and it also has to go through this. Now, remember, horizontal asymptotes, they can be crossed, but I know in advance that it's not going to do something like this, even though this is a function and it is approaching this horizontal asymptote. But the problem is right here. You crossed over the x-axis, making you have another 0. And again, like I said 100 times, this function only has one 0. 4 is the only number in the world that will make this function a 0. So that's helpful to me. I know that I don't cross over that x-axis, so I must stay just underneath it, but approaching it nonetheless. And then to the right of that point, it's approaching this vertical asymptote. So this is an extremely crude sketch of what this function will look like. We can, and we should, practice graphing it with our graphing calculator. So this is x squared. It's going to be parentheses. It's not going to like it. X squared minus x minus 6. And there is the function here. So as you can't see the asymptotes because they're not graphed, but you can imagine one right here at x equals -2 and one right here at x equals 3. Notice it's hitting the x-axis at 4, but then it's just hovering. Remember 5, the result was 1/14, so it's still pretty close to 0. But it's hitting through 4, 0, and then it's just curving downwards, approaching y equals 0, but never really reaching that. Okay, and then moving on. What about these slant asymptotes? Well, here's this function. Notice the degree in the numerator is greater than the degree in the denominator. So it doesn't have a horizontal asymptote. It has a slant asymptote, and the only way to find that would be to divide these two things. When you divide these two, the quotient is the slant asymptote. So let's graph this and see what it looks like. Get a new page. And I need parentheses. I need to group my numerator and denominator together. So I got x squared minus x plus 1. Divide that by parentheses x minus 1. And this looks kind of cool. I don't see any zeros here. So that tells me something. I don't see any zeros, so that's interesting. There is, of course, a y-intercept. If x is 0, the result is -1. Well, I can do that in my head. If x is 0, all I'm left with is 1 divided by -1. So that would be -1. And there looks like there's a vertical asymptote right here at x equals 1. Well, that makes sense too, because if x is 1, you're dividing by 0. So there is a vertical asymptote right here at x equals 1. But there looks like a slant asymptote right here. Now, what is that? We will find that out. First, the numerator, x squared minus x plus 1. If is prime, you can't factor it. But if I set that equal to 0, I would have to do quadratic formula. Since it's prime, I can't factor it. And the opposite of b, plus or minus, yada, yada, you should have that completely memorized. And look at what you get. Look at your discriminant. -3 is the discriminant. Since it's a negative number, you have imaginaries. And since the only thing that makes this 0 is an imaginary number, that means that they are not x-intercepts. We knew that from the graph already. And x minus 1 in the denominator indicates that x equals 1 is the vertical asymptote. Now, how do you find the slant asymptote again? We would have to divide. Luckily, we're dividing by a linear divisor, so I get to use synthetic division. So I put the 0 of the divisor right here. 1 makes x minus 1, 0. And these 3 are the coefficients of my polynomial. And I start the chain reaction by dropping down that 1, multiply, and then I add to get 0, multiply, I get 0, add, I get 1. Okay, well, I got 1 as a remainder. Remember, that means that I did not divide by a factor. And also, 1 is not a 0. I knew that already because when I knew that there were the zeros are imaginary. They're not real, and 1 is a real number. But this division results in this quotient, 1x plus 0, plus the remainder over the divisor, 1 over x minus 1. The quotient is your slant asymptote. So y equals whatever is right here. Y equals x plus 0, or more simply, y equals x. So that is how you find these slant asymptotes. You have to divide, and whatever the quotient is will be the asymptote. Let's go back to that graph. So I'm going to graph y equals x on here. And look at that. It just approaches that line y equals x on both sides. One more example to go. Another graph by following these 7 steps, except in step 5, instead of finding a horizontal asymptote, we're going to find the slant asymptote because I think that's the appropriate one for this. So step 1 is figure out if there's any symmetry. I've got this function right here. And if I plug in the opposite of x into the x's, I get the x squared cancels out the negative, but the x cubed doesn't. And I don't get the opposite of this, and I don't get the same thing. So again, we've got no symmetry. Finding the y-intercept, we could do mentally, I hope, I'm sure. You plug in 0 for x, what are you left with? -1 over -9, so that's positive 1/9. So I know there's a y-intercept of 0, 1/9. And then the x-intercepts, well, the x-intercepts are where the numerator equals 0. Now, do you remember how to factor x cubed minus 1? Do you remember that it factors into x minus 1 times x squared plus x plus 1? The x squared plus x plus 1, when you factor a difference of cubes, this quadratic is always prime. When it's x to the third. If you had like x to the 6th minus 1, then maybe some factoring can be had, but this is prime. And not only is it prime, but it actually produces 2 imaginary zeros. So if you were to put this in the quadratic formula, you would get 2 more imaginary zeros, which brings the total to 3. The degree is 3, so we're on the lookout for 3 zeros. One of the zeros is 1, and the other 2 zeros are imaginary. So that's a total of 3. But since only one of the zeros is real, there's only one real x-intercept. Now, you could have known that before, without knowing how to factor this. First of all, by looking at this, I hope we know that 1 would make this 0, because 1 cubed minus 1 is 0. But how could you know that there aren't 2 others lurking around? This is how you would know, just by knowing a little bit about transformations. First of all, x cubed, we know what x cubed looks like. It looks like this. Now, what about x cubed minus 1? Well, that's a transformation of going down 1. So just imagine this purple graph sunk down 1 unit. You'll see there'll be a 0 right here at this 1. Let me show you x cubed minus 1. And that's the green one. So this green one only has 1 x-intercept, so 1 real 0, and that's at positive 1. The other 2 are imaginary. All right, step 4 was find any vertical asymptotes. Well, the vertical asymptotes are the x values that make you divide by 0. And x squared minus 9, we know that that factors into x minus 3x plus 3. So there are two vertical asymptotes, x equals 3 and x equals negative 3. Since the degree of the numerator is greater than the denominator, there are no horizontal asymptotes, but there is a slant asymptote, and the only way to find that is to divide. Now you're dividing by x squared minus 9, so we're not going to use long division. We're not going to use synthetic division. We would have to do long division. So notice my placeholders, 0x squared and 0x, and I'm motivated to put something up here so that when I multiply both of these, I get x cubed. I cancel out that x cubed. So knowing in advance that I'm going to multiply x squared, I would put an x. So x times x squared is x to the third. X times negative 9 is negative 9x. And then I subtract. X cubed minus x cubed cancels out. 0x squared minus nothing is just 0x squared. Don't even need that. 0 minus negative 9 is positive 9. And then negative 1 drops down. Well, x squared, again, this 0x squared really doesn't belong there. But now, can I squeeze x squared into 9x? No, x squared is too great for the 9x. So this tells me that I'm done. So this division results in this quotient, x, plus the remainder, 9x minus 1, divided by the divisor, x squared minus 9. So on your quiz, this would be the final answer for a long division problem, this whole thing. But for us, we just want to find the slant asymptote, and that is the quotient. So it is once again y equals x. And this kind of divides up all of our numbers into sectors again. So here's a real number line, and step 6 is finding ordered pairs and plotting them. And before we do that, let's do let's plot what we got. We have a couple of vertical asymptotes. That'll be pretty handy. One at positive 3 and one at negative 3. Oh, yellow. No. And then I have a slant asymptote at y equals x. So my graph is going to be guided by these three asymptotes. Now, slant asymptotes can be crossed. Vertical ones will never be crossed because, again, vertical asymptotes are the x values that make you divide by 0. I know the y-intercept, it's 0, 1/9. So I'm going to try it. Yeah, that's impossible. So it's a little bit above there. And what else do I know? I have an x-intercept of 1, 0. And those are all the ordered pairs I know. But it divides it again into 4 sectors. One to the left of negative 3. In between this vertical asymptote and my 0. In between the 0 and my other vertical asymptote. And then everything to the right of this vertical asymptote. So I picked something to the left of negative 3. I just chose negative 5. And when you type in negative 5 into the function, you get 7.75. So negative 5, 7.75 up there. And then a value between negative 3 and the x-intercept of 1, well, 0 is in between there, and I already found 0. 0 got me 1/9. Now between 1 and 3, and of course I chose 2. If you plug in 2 into x, you get negative 1.4. So about there. Oops, a little bit. Oh, goodness. And then finally, a number past the last vertical asymptote. Anything bigger than 3, don't go crazy. I just did 4. If you plug in 4, you get 9. So 4, comma, 9. All right. Now try to graph this. First of all, the guidelines. Vertical asymptotes cannot be crossed. But the graph that we're about to graph, they approach vertical asymptotes and they approach the slant asymptotes. So I've got a problem here because, again, I've got these guidelines. I know that my graph has to approach this vertical asymptote and the slant asymptote. Now, it has to go through this ordered pair, but that's a problem because when I graph from this ordered pair to approach the vertical asymptote and then down to approach the slanted asymptote, I'm going to cross this x-axis, which gives me a 0. So did I miss a 0 somewhere? Is there another x-intercept that I don't know about? The numerator is x cubed minus 1. There's only one number in the world, one real number that would make x cubed minus 1 0, and that's the number 1. So can you figure out where I made a mistake? It's on the second page right here, and I'll give you actually just pause the video, see if you could find the mistake. Hopefully you did. It threw me for a little bit, but you probably found it right away, but -5, when you plug in -5 into x, you do not get 7.75. That's a mistake because -5, when you plug it into x, when you cube it, you get -125, and I put +125. So tisk, that's my bad. So that should be -125, which makes this -126. And -126 divided by 16 makes that -7.875. Which now, if you plug in -5 for x, you get -7.875. Now this ordered pair will be -5, comma, -7.875. And now I can actually sleep at night soundly because what I believe to be true is showing up here. I need to graph this function. It has to go through this ordered pair, but it also has to be approaching these two asymptotes. And I can do that by just zip, 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 like that. It looks something like that, much prettier than what I just did. The section on the upper right has to go through this ordered pair. And again, it's guided by the asymptotes. So something like this. Good night. And finally, my middle section, don't worry about crossing that slanted asymptote. Asymptotes can be crossed. Vertical ones can't, but all others I can, I believe. And I know I must approach both vertical asymptotes. I must. And you see how these three guide me. It's going to be kind of curving down through here. Oh God, let me do that one again. You get the idea. Something like that. And that is it. So let's see how we did. Let's go to our TI Nspire and let's graph this puppy. So I've got in the numerator x to the third minus 1 divided by parentheses x to the second minus 9. And well, I've got vertical asymptotes, but I believe I have vertical asymptote at 3 and -3. Let's zoom out. Okay. So, and pressing escape will undo the whatever function you were in. So this is what the graph looks like. We've got this inflection cubic looking part in the middle here. And remember, our three ordered pairs guided us through there. And then clearly a slant or asymptote right here, which happens to be y equals x. Two vertical asymptotes, one at -3, one at +3, and only 1, 0 of x equals 1. Remember, this is 42 way out here, so x equals 1 is hard to see. It's in there somewhere. Very much hope that was okay for you, and we'll see you tomorrow in class. There is an assignment on my math lab for this.